Section 210.52 Code of the National Electrical Code addresses the requirements for general-purpose branch circuits in commercial spaces. This section stipulates that outlets for lighting and appliances must be installed in such a way that no point along the floor line of a space or area is more than 12 feet, or 3.66 meters, from an outlet in any direction of horizontal measurement. This regulation ensures convenient access to electrical power throughout the commercial building. Understanding this rule is crucial for electrical contractors and building designers to ensure code compliance and usability. The 12-foot rule aims to reduce the reliance on extension cords which can pose safety hazards and create an unsightly environment. Adhering to this spacing requirement promotes a safer and more efficient workspace. Compliance with Section 210.52 Code involves careful planning during the design and installation phases. Electrical contractors should assess the layout of the commercial space and strategically position outlets to meet the maximum spacing requirement. Consider the intended use of the space and the anticipated placement of furniture and equipment. Strategic planning can minimize the need for future modifications or additions. Factors that may influence outlet placement include the presence of fixed furniture or equipment, the location of walls and partitions, and the overall layout of the space. Collaboration between architects, designers, and electrical contractors is essential to achieve optimal outlet placement. The application of the 12-foot rule requires precise measurement techniques. Electrical contractors must accurately measure the distance from each outlet to the farthest point along the floor line of the space. Laser distance measuring tools can aid in ensuring accurate measurements. Careful documentation of outlet locations is also important for future reference. Non-compliance with Section 210.52 Code can result in code violations and potential safety hazards. Electrical inspectors will typically verify outlet spacing during building inspections. Failure to meet the required spacing may necessitate corrective action such as the addition of new outlets. Addressing code violations can be costly and time-consuming. It is always best to ensure compliance from the outset. In addition to the 12-foot spacing rule, other relevant sections of the NEC may apply to outlet installations in commercial spaces. These may include requirements for outlet height, grounding, and overcurrent protection. A thorough understanding of the NEC is essential for all electrical contractors and installers. Regular training and continuing education can help ensure that electrical professionals stay up to date with the latest code requirements. Proper outlet installation not only ensures code compliance but also contributes to the overall safety and functionality of the commercial space. Well-placed outlets can improve productivity, reduce the risk of electrical hazards, and enhance the aesthetic appeal of the building. Electrical contractors should prioritize quality workmanship and attention to detail in all outlet installations. Using high-quality materials and following established best practices can help ensure the longevity and reliability of the electrical system. Regular maintenance and inspection of outlets can also help identify and address potential problems before they become serious. A proactive approach to electrical safety is essential for maintaining a safe and productive work environment. Section 210.52 Code is a critical component of electrical safety in commercial spaces. By understanding and adhering to this regulation, electrical contractors and building owners can create safer and more efficient workplaces. The 12-foot rule is not merely a technical requirement, it is a fundamental principle of electrical safety and usability. Remember the importance of careful planning, accurate measurement, and quality workmanship in all outlet installations. The NEC is regularly updated to reflect advancements in technology and changes in industry best practices. Electrical contractors should stay informed about the latest revisions to the code and adapt their practices accordingly. Consulting with experienced electrical engineers and inspectors can also provide valuable guidance on complex code issues. Investing in ongoing training and professional development is essential for maintaining competence and ensuring code compliance. Ultimately, the goal of Section 210.52 Code is to create a safe and convenient electrical environment for occupants of commercial buildings. By prioritizing code compliance and quality workmanship, electrical contractors can contribute to the well-being and productivity of the community. Electrical safety is a shared responsibility, and everyone involved in the design, installation, and maintenance of electrical systems should be committed to upholding the highest standards of safety. The 12-foot rule is a simple but effective measure for preventing electrical hazards and promoting a safer work environment. Let's delve a bit deeper into some practical considerations for implementing Section 210.52 code in different types of commercial spaces. Firstly, consider open office areas. In these large, often flexible spaces, outlet placement requires careful planning to accommodate various workstation configurations. It's often beneficial to use a grid pattern for outlet placement, ensuring that no point is more than 12 feet from an outlet, regardless of how workstations are arranged. Power poles, which bring power from the ceiling, can also be useful in open office areas where it's difficult to run wiring through walls. Secondly, think about retail spaces. Retail environments often have unique power needs, with displays, cash registers, and other equipment requiring convenient access to outlets. Consider the placement of displays and plan outlet locations accordingly. In some cases, it may be necessary to install additional outlets to accommodate seasonal displays or special events. Thirdly, consider restaurants. Restaurants have particularly demanding power needs, with kitchen equipment, lighting, and point-of-sale systems all requiring reliable power. In the kitchen area, outlets must be strategically placed to serve appliances while complying with spacing rules. Consider using ground fault circuit interrupter or GFCI protection for outlets near sinks and other wet areas. Fourthly, focus on healthcare facilities. Healthcare facilities have stringent electrical safety requirements due to the presence of sensitive medical equipment. Outlets must be installed in accordance with all applicable codes and standards, including those related to patient care areas. Consider using isolated ground outlets for sensitive electronic equipment. Fifthly, think about industrial settings. Industrial environments often have heavy power demands and require robust electrical systems. Outlets must be suitable for the intended use and protected from physical damage. Consider using weatherproof outlets in areas exposed to moisture or dust. When planning outlet installations, remember the importance of future flexibility. Commercial spaces often undergo renovations or changes in use, so it's wise to design electrical systems that can adapt to future needs. Consider installing extra conduit or empty junction boxes to facilitate future wiring changes. Also, ensure that electrical panels have sufficient capacity to accommodate future loads. Remember the importance of proper grounding. Grounding is essential for electrical safety, preventing electric shock and reducing the risk of fire. Ensure that all outlets are properly grounded and that the grounding system is properly connected to the building's electrical service. Regularly inspect the grounding system to ensure its integrity. Also consider surge protection. Surge protection can help protect sensitive electronic equipment from damage caused by voltage spikes. Consider installing surge protective devices, or SPDs, at the electrical panel and at individual outlets. Surge protection is particularly important for computers, servers, and other electronic equipment that are susceptible to damage from power surges. When selecting outlets, choose high-quality products that are suitable for the intended use. Consider the amperage and voltage rating of the outlet, as well as its environmental rating. Use tamper-resistant outlets in areas where children may be present. Always follow manufacturer's instructions for installation and maintenance. Proper labeling is also essential. Label all outlets and circuit breakers clearly to identify the circuits they serve. This will make it easier to troubleshoot electrical problems and perform maintenance. Use permanent labels that are resistant to fading and wear. The NEC also includes requirements for the height of outlets above the floor. These requirements vary depending on the type of occupancy and the location of the outlet. Consult the NEC for specific height requirements. Consider the accessibility of outlets for people with disabilities. The Americans with Disabilities Act, or ADA, includes requirements for the height and location of outlets in accessible spaces. Ensure that outlets are within reach range for people using wheelchairs. The NEC also addresses the use of extension cords. Extension cords should only be used as a temporary solution and should never be used in place of permanent wiring. Avoid overloading extension cords and never run them under carpets or rugs. Regularly inspect extension cords for damage and replace them if necessary. Remember that electrical work should only be performed by qualified electricians. The electrical work can be dangerous, and it's important to hire a licensed and insured electrician to perform any electrical installations or repairs. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and in accordance with all applicable codes and standards. Don't attempt to do electrical work yourself unless you are properly trained and qualified. The 12-foot rule of Section 210.52 current is a fundamental requirement for electrical safety and usability in commercial spaces. By understanding and adhering to this rule, electrical contractors, designers, and building owners can create safer, more efficient, and more productive work environments. Always prioritize code compliance, quality workmanship, and ongoing training to ensure the safety and reliability of electrical systems. It is also crucial to consider other factors influencing outlet placement. These include the type of equipment being used, the layout of the space, and any potential hazards. High traffic areas, for example, may require more strategically placed outlets to avoid tripping hazards. In manufacturing facilities, the specific needs of machinery and equipment must be taken into account when determining outlet locations. Consulting with engineers and facility managers is essential to ensure that the electrical system meets the unique requirements of the space. Accessibility is another critical consideration. Outlets should be easily accessible for maintenance and repairs. Avoid placing outlets behind large pieces of equipment or in hard-to-reach locations. Proper planning and coordination can ensure that outlets are both functional and accessible. The selection of appropriate outlet types is also important. Consider the amperage and voltage requirements of the equipment being used and choose outlets that are rated accordingly. Use heavy-duty outlets for equipment that draws a significant amount of power. GFCI outlets should be installed in wet locations to protect against electric shock. Surge-protected outlets can help protect sensitive electronic equipment from damage caused by power surges. Remember to always follow manufacturer's instructions when installing outlets. Incorrect installation can lead to electrical hazards and equipment damage. Use the proper tools and techniques to ensure that outlets are securely mounted and properly wired. Double-check all connections before energizing the circuit. Proper labeling is essential for identifying circuits and outlets. Use clear, durable labels that are easy to read. Label each outlet with the circuit number and the equipment it serves. This will make it easier to troubleshoot electrical problems and perform maintenance. Regularly inspect outlets for damage or wear. Replace any damaged outlets immediately to prevent electrical hazards. Check for loose connections, cracked housings, and other signs of wear. A proactive approach to maintenance can help prevent costly repairs and ensure the safety of the electrical system. Consider the use of energy-efficient outlets. Energy-efficient outlets can help reduce energy consumption and lower utility bills. These outlets are designed to minimize standby power losses and provide efficient power delivery. While not directly related to the 12-foot rule, energy efficiency is an important consideration for any electrical installation. Smart outlets offer advanced features such as remote control and energy monitoring. These outlets can be controlled remotely using a smartphone or tablet. They can also track energy consumption and provide valuable insights into energy usage patterns. Smart outlets can be a valuable tool for managing energy costs and improving overall energy efficiency. The NEC provides detailed guidelines for the installation of electrical systems. It is essential to consult the NEC and other applicable codes and standards when planning and installing electrical outlets. These codes are designed to protect people and property from electrical hazards. Staying up to date with the latest code revisions is crucial for ensuring compliance and safety. Consider the aesthetic impact of outlet placement. While functionality and safety are paramount, the appearance of outlets should also be taken into account. Choose outlet colors and styles that complement the surrounding decor. Conceal outlets where possible to minimize visual clutter. A well-designed electrical system can enhance the overall aesthetic appeal of a space. The use of modular wiring systems can simplify outlet installation and reduce labor costs. Modular wiring systems consist of prefabricated cables and connectors that can be quickly and easily assembled. These systems are particularly well suited for large commercial projects where a significant number of outlets need to be installed. Consider the impact of outlet placement on future expansion or renovation. Design the electrical system with enough capacity to accommodate future growth. Leave room for additional outlets and circuits as needed. A flexible electrical system can adapt to changing needs and avoid costly modifications in the future. Proper planning and coordination are essential for successful outlet installation. Work closely with architects, engineers, and contractors to ensure that the electrical system meets all requirements and is properly integrated into the overall building design. A collaborative approach can help prevent problems and ensure a smooth and efficient installation process. Regular training and education are essential for electrical professionals. Stay up to date with the latest technologies, codes, and best practices. Attend industry conferences and workshops to learn from experts and network with colleagues. A commitment to lifelong learning is essential for success in the electrical industry. The 12-foot rule is a critical component of electrical safety in commercial buildings. By understanding and applying this rule correctly, electrical professionals can help create safer, more efficient, and more productive work environments. Remember to prioritize code compliance, quality workmanship, and ongoing training to ensure the safety and reliability of electrical systems. Also, documentation is key. Keep detailed records of all outlet locations, circuit numbers, and other relevant information. This documentation will be invaluable for future maintenance, repairs, and renovations. Use a consistent system for labeling and documentation to ensure accuracy and ease of use.